Hey everyone. So this is Algebra 1, Lesson 5-2. Unit 5, we're talking about functions. So today we're going to talk about the definition of a function. So we're going to talk about functions and other things called relations, and talk about how to tell the difference between them, um, and then talk about some of the properties of functions and relations, specifically the domain and the range. So a lot of vocabulary in this lesson. So let's just kind of get right into it. So the first thing we're going to talk about is a relation. And a relation is just simply a set of points, right? It's a set of ordered pairs of an XY ordered pair. It can be an infinite set of points. It can be a finite set of points. But it's just some set points. So yesterday, in the previous lesson, we talked about how to define or how to notate, right? How to talk about different kinds of sets, infinite sets, and things like that. So a relation is a type of set, and it's just a set of not numbers, but a set of points. We talk about the domain of a relation, and the domain just simply represents the x values of a relation. Right? So it's all the sets of the x coordinates of all the points in that relation. And then likewise, the range is the y values. Okay, so if we think about a graph, right? The domain, right, are all the values going across the x-axis from left to right. And in the range, it's all the values in the y-axis, so going from bottom to top, right? So when we talk about domain and range, if it's a finite set of points, we talk about those in terms of the numbers, and the way that we list those numbers is from smallest to biggest. And if there's any repeating values in there, right, if there's a number that shows up twice, we simply omit it. Okay, so it's just the unique numbers that are in that set of points. Okay, and then a function is a specific type of relation. A function is a relation that has the property that there's only there's unique members of the domain, and every member of the domain only has one range in it. Okay, so every domain only matches up with one range member, and we'll look at some examples of that in just 1 second. All right, so we have these four things. We have a relation, properties of a relation, or some of the things that make up the relation. It's a set of points. The domain is the set of all the x values. The range is the set of all the y values. And a function is a specific type of relation that has specific properties that we'll go into in just a second. So we have some different ways of representing functions. So one way is using set notation. So we talked about set notation or set builder notation yesterday. It uses those curly brackets, right? Those curly brackets means a set of things. And so this is a set of points. And so here we have some set notation. So this is a set. It's a finite set. There's only 3 points in this set. Okay, so there's the first point, second point, third point. Oh, it's a set of points. The curly brackets means it's a set. The round brackets inside there denote each one of the points. And then this is the x part of each point and the y part of each point. Okay, so in this set, we would say that the domain of this set are the numbers 1, 3, and 5. And the range is the y values. We'd say the y values are 2, 4, and 5. Okay. So remember, we talk about those points in order. So they don't necessarily match up. When we talk about the domain, we talk about the range, we list those out. They don't necessarily need to be in the same order. They just need to be in ascending order, right, from smallest to largest. So this is set notation. Another way that you'll sometimes see relations written out is with what's called a mapping. Okay, so in a mapping, they show the two right? Sets of numbers here. This is the domain numbers on the left. So 1, 3, and 5. Again, they're written in order from smallest to largest. And then these are the range numbers on the right-hand side. So again, in order, right? 2, 4, and 5. And the mapping shows how those things are related. So 1 goes with 5. So 1 and 5 have a relationship. Okay. 3 and 4 are related. 5 and 2 are related. So that's why we call it a relation. Those numbers are associated with each other, or they have a relationship with each other. So this is the second way, a mapping. A graphical way, right? A graph is another way of showing a relation. And so here we just graphed out each one of those points. Again, this is a finite set, so there's only 3 points in this. So we can just see the 3 dots there. Each dot represents one of the points on that. You can see the domain numbers, right, go from left to right. The domain numbers are 1, 3, and 5. And the range numbers are from bottom to top, right, from smallest to biggest, 2, 4, and 5. So there's a graph. And then the last way we have here is with a table of values. It's not the last way, it's another way. Right? So a table of values. And so a table of values, we just list out the points. Okay. Now with the table of values, we list out the X and Y. We show how they're related, right? So the X and the Y values that are related are listed with each other. The X and Y values that are related are listed with each other. So 1 and 5, 3 and 4, 5 and 2. Okay. So when we talk about the domain is the X values, right? And these just happen to be written in order. The Y values are not necessarily written in order. They're shown how they're related to the X value. So here we have the domain on the left and the range on the right. So one of the things that we're going to have to do here is talk about whether something's a function or not. So let's go back and look at our definition of a function. A function is a relationship, right, where every member of the domain matches with only one member of the range. So let's look at our example here. We have this example of this finite set, right, of these 3 points. And so the question is this relation, is it a function? And so the way that we can tell is we look at the X values. We look at the domain. Every member of the domain has to go to only one value in the range. 1 here only goes to 5. Okay? 1 doesn't go to 5 and 2, right? It only goes to 5. 3 only goes to 4, and 5 only goes to 2. Okay? So in that, we would say, yes, this is a function. Okay? It's a function because every member of the domain goes to only one member of the range. So let's take a look at this relation here. Here we have another finite relation, right? A finite set of points. And the question is this a function? And so I'm going to look at these, right? So let's look at these and see what's my domain. Well, my domain here, right, is going to be the set of points. And so I'm going to write a curly bracket here. The set of the X values. So the smallest number I have here is 3. 4. I have another 3, but since it's listed there twice, I'm only going to list it in my domain once. So 3, 4, and 5. So 3, 4, and 5 are the numbers in my domain. I look at the range numbers are, the smallest one here is 1, and then 2, and then 5, and then 6. Okay, so there's the domain and there's the range. Okay, so we've just listed those out. We haven't really answered the question, is it a function? I can see already that I don't think it's a function. I'm going to list it out here one other way here. I'm going to list this as do a mapping of it. So if I list my domain here, right, and I just go 3, 4, 5, and I list my range out, my range here, is 1, 2, 5, and 6. And if I kind of draw lines in between these, right, to show how they're related, well, I know that from here that 3 goes to 2. So 3 and 2 are matched up. I know that 4 and 5 are matched up. And I know that 5 and 6 are matched up. But I see right here that 3 and 1 are also matched up. Okay, so this tells me that this is not a function. So is this a function? No. Why? Because, I'm going to type it out here. Because three in the domain goes to 2 and 1 in the range. So this goes against the definition of a function. 3 in the domain goes to multiple numbers in the range. So this is not a function. Visually, I can see it here. I can see 2 lines coming off of 3. So 3 in the domain is going to 2 different numbers. That tells me that it is not a function. Look at the next example. Is this a function? Well, let's go through the same sort of exercise here. So if I list out my domain is, looks like 3, 4, and 5 again. Notice that I've got 2 3s in there. Okay, so that tells me that maybe there's something up with this. If I list my range here, my range is -2 is my smallest number. And then 1, and then 2. And I notice that 1 shows up twice in my range. So is this a function? Well, I've got 3 here in the domain, right? That's listed twice. But when I look at what is 3 mapped to, right? What is 3 associated with? So if I list out my domain and my range, well, 3 goes with 1, 4 goes with 2, 5 goes with -2, and 3 goes to 1 again. Notice that 3 in the domain only goes to 1. It happens to do it twice, but it only goes to 1. So is this a function? Yes, it is. So each member of the domain goes to only one member of the range. Oops. Okay, so each member of the domain only goes to one member of the range. So there's a unique mapping there, right? So here we have a mapping, right? And the question is the same, is this a function? So let's go through this. Here I've got, it looks like I've got 4 points, right? So a finite set here. And if I listed out those points, right, it'd be 4, 12, 5, 18, 7, 12, and 8, 19. And the question is it a function? Well, if I look at, again, my definition of a function, I have to look at every member of the domain. So 4 goes to 12. 4 doesn't go to any other numbers. 4 only goes to 12. The domain 5 only goes to 18. The domain 7 only goes to 12. And the domain 8 only goes to 19. So based on the definition of a function, yes, this is a function. Now, you may be thinking, well, what about this? We have 2 numbers that go to 12. If we look at our definition of a function, it doesn't say anything about the range going to only one domain. It only says the domain goes to one range. Okay, so we're only looking at this relationship going from the domain to the range. So 4 only goes to 12, 7 only goes to 12, 5 only goes to 18, 8 only goes to 19. Yes, this is a function. Okay, yes. Each member of the domain. It goes to one number of the range. Okay, so here we have another example, another mapping example. So see the domain and range listed. We can see the domain and range listed out there. So is this a function? Well, let's check the domain, right? 1 goes to 12, 2 goes to 8, 4 goes to 1, but 4 also goes to 7. So I can tell from this representation, right, that this is not a function. 4 in the domain goes to 2 numbers in the range. So is this a function? No. 4 in the domain goes to 1 and 7 in the range. Okay, so we don't have that unique map. So here we have a graph. Right? So we have a graph, a graphical representation of this. Notice that our graph doesn't have any numbers on it, so I can't create a list of the domain and a list of the range and compare them that way. So how do we do this, right? How do we tell what's going on here? Well, if we look at our domain, right, is along the x-axis. So if I look along the x-axis here, I can say, well, right here, right here, let's get my graph set up here. So right here, right here, I have an x value. And I can see that that only goes to 1 point. So this x value only goes to one y value. Right? And likewise, this x value right here only goes to one y value. This x value, right, only goes to one y value. This x value here only goes to one y value. That's a little off there. Get the idea. Now, if we look at this last line here, we look at the last line here, right? That last line, if I look at this, right, this x value goes to multiple y values, right? It's hitting this point and this point. So if I look at my y values here, right, this x value goes to 2 different y values. So because of this situation right here, where we have these 2 points sitting on top of each other, right, this is not a function. This is not a function. Okay, I have an x value here that's going to 2 different y values, one y value up here and one y value down here. Okay, so what we call this is the vertical line test. So if we have a graph, we can look at a vertical line and we can say, well, let's take this imaginary vertical line here, right? And let's move it back and forth along the x-axis. Let's look along our domain here, right, along the x-axis and see, well, it only hits 1 point. Here 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 it hits 2 points. So this x value goes to 2 different y values. Okay, so this is called the vertical line test. And so is this a function? I would say no. And the reason I would give is because graphically I can see this fails the vertical line test. Vertical line test. All right, so graphically we can tell just by kind of looking at that graph and imagining that vertical line going through there. If that vertical line touches 2 points at the same time, it is not a function. So here we have another graph. So we can quickly just kind of apply that vertical line test. Again, I can kind of set up my vertical line here, right? And in my head, I can just move this back and forth. And you say, well, is this hitting more than 1 point at a time? right? And it's hard to tell, but it doesn't look like it, right? It doesn't look like it. All right, so I would say, is this a function? I would say, yes, this is a function. Because it passes the vertical line test. Okay, so let's take a look at this function here a little bit and kind of look at how this function is different than the other functions, right? All the other functions we've been looking at have been finite sets, right? They've been a fixed number of points. This one here, this is all of the points, right, that lie on this graph. In fact, you can say that this line, right, the line of this graph is actually just all of the points laying on the graph at the same time, and then they just all connect and then make that shape. So this is an infinite number of points here. Even though it looks like it has a fixed start and end, there's an infinite number of points in between these two things, right? So, so this is an example of, an infinite set. So, but it's still a function. Now, if I were to ask about the domain and range of this function, I couldn't just list out the numbers because there's an infinite number of them. So I would have to use some of the other notation things that we've talked about. And so we're going to talk about those domain and range things here in just a little bit. All right, so here we have another graph. And so we want to know, is this a function? I've got a graph, so I'm going to go ahead and use the vertical line test. So I'm going to just drop a vertical line in here. And I'm just going to move this along here. And, it looks like it passes the vertical line test. There may be a question right here, right? It looks like maybe, those points are close to being vertical. But because I can kind of tell, well, those are arcs. Whoops, those are arcs, right? They're like half circles, it looks like. So this is what's called a tangent point. So this is not technically, overlapping points here. So I would say that this graph passes the vertical line test. Now, I could be wrong, but based on my evaluation of this, right, I would say that this passes the vertical line test. Okay. So is this a function? I would say yes. It passes the vertical line test. Okay. And then we want to talk about the domain of this. Right? So when we talk about the domain, remember I want to list out all of the x values. Okay, so I want to start at the smallest x value, and I want to go up to the biggest x value. I'm going to use interval notation for this. And so I can see that I've got some dots at the end, so I know that that function stops at -8 and it stops at +8. Okay, so when I list my domain, I'm going to list this in interval notation. So I'm going to say that it goes from -8 is my smallest number, and it goes to +8 is my biggest number. Okay. And I've got a solid dot on the end of that, which means that it includes 8 and it includes -8. So I want to use square brackets on the ends of this. So there's my domain. So I'm going to look from left to right, right? I'm looking at my x values. I'm looking at the values along the x-axis. And so it goes from -8 to +8. Now, when I talk about the range, okay, I'm going to talk about the y values. So I'm going to go along the y-axis, right? And I'm going to start at the bottom of this graph. It looks like the bottom of this graph is right here at -4. And it looks like it goes through that point. So my range is going to be from -4, right, in the y values. And then if I go up here and look at the top of my graph, well, the top of my graph is right here. It's at +4. So it looks like it goes from -4 to +4. And I think it goes through those, right? There's not a hole there. There's not an open dot or a break in the graph there. So I think it's continuous through there. And so I'm going to use square brackets on those ends. Okay, so the domain is going from the left to the right. The range is going from the bottom to the top. okay? The bottom and the top aren't necessarily the endpoints. So keep that in mind. That's a place that a lot of people get confused on. It's from the bottom of the graph to the top of the graph. I'm looking at the y values. Okay, and then the last thing I want to touch on is what's called function notation. And you'll see this kind of used interchangeably. So when we start talking about functions, right, we talk about it in a slightly different way, or we note it in a slightly different way. We talk about a function, we can give a letter name to that function. And so in this case, I would say that this function here is called f. Okay, this is called f. And f takes x as its input. So that's what this function notation means. This means this is a function called f, and x is the input of that function. And then to find the output, I would take x, I would divide it by 2, I would take the opposite of that, and then I would add 6 to it. Okay, so this tells me the rule for, how to figure out the value of that function. Okay, these two things mean exactly the same thing. This is equation notation here. This is function notation. Okay, the input in this is x, and my output is y. The input here is x, my output is f of x. So if I wanted to figure out what this would be, if I put 3 in for x, this is the way I would denote that. So I'm going to evaluate this function f when x is equal to 3. So we would say this is f of 3. So f of 3, and what that means is I'm just simply going to put in 3 into this. And so I would take negative, my x value is 3, I would divide that by 2, and I would add 6. Okay. So that's 6 minus 1.5, that's going to be 4.5, right? 4.5, or that's going to be, what is that, 9 halves. So 9 halves. So here I would say f of 3 is equal to 9 halves. Okay. If I plugged 3 into this equation, well, I would say that y is equal to negative 3 over 2 plus 6. And I get the same answer, but I just list it differently. I would say here the y value is 9 halves. Now, the advantage of using a function notation is that when I say that y is equal to 9 halves, if I just have that piece of information, I don't know what x value goes with that. I don't know what value I plugged in here to get 9 halves. Okay. If I had my work here, I could look back and see. But if I just said that, well, here's an equation, and I know that y is equal to 9 halves, I don't know what the x value is. Right here, I do. If I say this is my function, right? And when my function is 9 halves, that's when I used an input of 3. And so that's the advantage of using function notation, is that you can see both the input and the output in that same notation. Okay. The other value is that I can call these functions whatever I want. Okay, a lot of people use f just because the word function starts with f, but I could have a function called g. I could have a function called h. I can call it, whatever I want, right? I can use whatever value I want. All right, and so I can talk about the function f versus the function g versus the function h, and I can do things with that. I can add f and g together. I can, do other things like that. So function notation opens up some possibilities for us that we're going to take advantage of moving forward. All right, so that's function notation. So that's actually that's a part of our next assignment as well. So 5.2 and 5.3 is talks about function notation. So we'll go ahead and end the lesson here. So take a look at the assignments and let me know if you have any questions.